Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see Clapeyron's three-moment equation. Means how to find the Clapeyron's three-moment equation. That derivation. First, what is that? The three-moment equation gives us the relation between the moment between any 3 points in a beam and their relative vertical distance. So see here, at any 3 point in a beam and their relative vertical distance or deviation. So their relative deviations, we can find this that part how much it will get deviate. Okay, this method is widely used in finding the reaction in a continuous beam. So if beam is continuous, then it's not necessary at all the point the same bending will be there. So at positive, if a long beam is there, then chances are there for different bending also. So means by this method we can find that also. So now this is consider 3 point on the beam loaded as shown in figure. So this is any type of loading. So which type of loading? At the end we will see in the table that how we will find or how we can determine that load. So this is what? This is just we are taking the general load. Later we will replace this by either point load, uniformly distributed load, or at any distance depending upon the requirement. So this is the load acting here, this one. So now just see this curve. So because of this, it should be bent like this here. Right. So here just take in height, this as H2 and this as H1. Okay. So now this only we have to find. So just see, this is up to L1 distance, not from here beginning. This is split up to L1, and from here to here the other side of the load is L2. So now this loading part we are dividing into two parts because different length is given. If same length is given, then we can, or same type of load is given, then we can. But chances are there that more than one load also will be there. Just see in that case what happened. So now first we are taking this part, first part. So here this is the load from where to where? L1. Total length is L1. So just take here this as V1, V1 and V2. Right? So loading that moment will be what? In this direction M1, and from here M2. So this for this part. Similarly for second part, for this part means from here to here. So this will be what? Anti-clockwise. Sorry, this will be clockwise and M3 will be anti-clockwise over length L3. So now here this is for V2 to V3. Now what we have to do? We have to draw the moment diagram of simply supported beam. Right. So overall this will be from here at A1 and B1 if at that they are not at the same distance. Okay. So moment diagram and A2 to B2. Right. The next here, let's see, bringing this one. Right. M1 will be here more in this case, and this M2 will be here in this direction. So this is M2 and this is M1. In this case, M2 is again smaller, so M2 will be here and M3 is this one. So this is what? The bending, the moment diagram of loading by end moment. This is because of supported span. So this one is because the moment diagram of load on simply supported span, and this is because of this load only. Right. So now for that we have to find. Right. So now let's see next step what we will do. So let's see here. This we are taking this part. This curve here, this H1, H2 is given. So that only we are taking. Right. So here, let's see, this is L1, this is L2. So for L2, moment will be like this. That's what we have seen here. Right. This M3 and M2 will be this side bigger. So this is for M1 at a distance L1, L2. Now from here to here, what we assumed in this figure, let's see, that is H1 here, this total curve. Right. So up to this is H1. This up to moment after this, what we have taken just T1 to 2. T1 to 2, T1 by 2 is not then. This is 1 to 2. This, whatever the gap is thickness of 1 to 2 is this one. right? So what about this will be there? This is H1 and this is T1 to 2. So this will be what? This part H1 minus T1 to 2. Similarly for this side, this is given as H3, right? This is 3 to, this total is what? 3 to 2, right? 3 to 2. So 3 to 2. So this will be what? T3 to 2 minus H3, this one. So now we have this distance, we have this distance. We know already this, we know already this. Now just see, we will apply some property to show these two triangles are similar or not. So let's check. Let's see. For this triangle, this angle will be equal to this angle. But this side is common for both the triangle, and this side is also common for both the triangle. Means this side, this triangle is similar, right? So two sides and one angle. So this side is similar. Now we will apply the similar triangle property. So for similar triangle property, what is that? This height, right? So this means this height is what? H1 minus T1 to 2. This height if you are taking, then we have to take this side. Divided by T3 to 2 minus H3 will be equals to what? This one. L1 by L2. So take this L1 this side and this side. So H1 minus T1 to 2 by L1 is equals to T3 to 2 minus H3 by L2. Right. It's not necessary that you can take also this divided by this one, then this divided by this one. That also you will get the same thing. Okay. Now next what we will do, we will just separate the terms. So now from here H1, can we write this as, here this H1 by L1 minus T1 to 2 by L1 is equals to T3 to 2 by L2 minus H3 by L2. Right. Now T term one side, H term one side we are taking. So now after this what we can write? This is H1. So take here. So now H1 by L1 plus H3 by L2, that is equals to this, and this will go this side, so it becomes plus. So T3 to 2 by L2 plus T1 to 2 by L1. Right. So that is here. T1 to 2 by L1 plus T3 to 2 by L2, that is equals to what? H1 by L1 plus H3 by L2. Just take this as equation. So now we have this value from this figure. Okay. Now we have to find what? This T1 to 2, T3 to 2. How we will find? So just see here. Values of T1 to 2 and T3 to 2. So first for T1 to 2, 1 by EI, right? That force. This T1 was that strain, that from deflection. That what is the formula? Delta L equals to PL upon. So from here, this will be what? 1 by EI, area 1 to 2 into x1 will give you the thickness. Right? Now, what we have to find? This x1 value. So how we will find? So just see, this is average, this one. So now 1 by EI common, area of 1 to 2, that A1, right? And this small A1 cross section. So just see here that figure, right? That already given in the question itself. So that is the area for part A. Similarly for part B, B will be the area A to B. So A1 A, right? Plus now for this value, so half M1 L1. This is what? Area of the triangle, right? Half M1 L1. See the triangle. Half M1, or here half M1 and L1. That will be the area of the triangle. Into where that will act? This average shear center that at, because we know in the triangle it's acting at L by 3 distance. So here L1 by 3. Similarly, this is for first slope. Similarly for what? This will be half M2 L1, right, area, and from this side if 1 by 3 is there, then other side it will be 2 by 3 L1. So this is, so now just see once again, A1, capital A1 and average small a1, that will be the moment because of the overall, or just remaining that when. So later we will see what is a1 and a in that table. So now after this what you will get 2, or just let me simplify this term. So yeah, just see 1 by e1 I1 constant. Okay, now keep this as a1 into a1 bar, plus after multiplying this what we will get 1 by 2, that is 1 by 6 m1 l1 square, plus here 1 by 2, so 2 by 6 m2 by 6 m2 l1 square. Okay, so this is now for that what we will do, multiply 6 so that this will get cancelled. So now we have 1 by ei e1 I1 multiplying 6 with each term, so this will becomes 6 a1 a bar, plus now this 6 will get cancelled, so m1 l1 square, plus similarly here this will get cancelled, so now this becomes what, 2 m2 l1 square. So this is here t1 to 2. Now this we know m1 l1, this one, so this is 6 a1 a dash 1. What will be that we will see later, which type of load is acting. Okay, so this is for overall load. Once we will replace the load, in last we will see the tabular form, what value of this will be there for which type of loading, right? So just now keep this in mind. So similarly we will find for what, t3 to 2. So 3 to 2, again the same way, e1 by e2 I2, area from 2 to 3 into x3, that we have to take from this side. So this one same, again for area E2, so A2, B2. Now M2, L2 you have to take, just see the figure, right? M2, L2, and similarly for M3, L3. So from this side, half M2, L2 into 2 by 3 L2 plus 1 by 2 M3, L2. So this is the area of the triangle and this is the distance. So where this side 1 by 3, so this side what, 2 by 3, right? See here. So from here, if this side we are taking, because from this side, so this side 1 by 3, so from here this distance will be what, 2 by 3L. So because this side it's at 1 by 3L. Okay. So now this is there. So again what we will do, again we will multiply here. So this will be what, A1 by E2 I2, A2 B2 plus 1 by 2 M2 L2 and this 2 by 3. So 2 by 3 multiplying it, 2 by 6 M2 L2 square. Similarly here 1 by 3 and 1 by 6. So 1 by 6 M3 L2 square. Next step what? Multiply again by 6, or let me do this one. So T 3 to 2 is equals to 1 by E2 I2, right? And then this is A2 B2 bar plus, now this becomes 2 by 6 M2 L2 square plus this is 1 by 6 M3 L2 square, right? Now with each term we will multiply by 6, so that denominator becomes that, just for simplification. So 1 by E2 I2, so multiplying with 6, so this will be what, 6 A2 B2 bar plus 6 by 6 will get cancelled, so this will be 2 M2 L2 square plus here 6 cancel, so M3 L2 square. So now we got this one, right? So here we are multiplying, then what we have to do, we have to divide also. So another 6 will be here also, just like this one, right? I means that just multiply and divide by 6. So this term will get multiplied, this will 6 will get cancelled, right? So now finally what we have, T3y2 is 1 by 6 E2I2 into 6A2 B2 plus 2M2 L2 square plus M3 L2 square. So now we have T1 T3. Now let's substitute these value in this equation, right? So now just see after substituting what we will get. Substituting T12 and T32 in equation 1. Which one? That is in this one. So let's substitute. Whatever value is there, just you have to divide by what? L, because dividing by L1 here is coming. So for T1 to 2, okay, or just first write T1 to 2. So what is T1 to 2 here? So first term is T1 to 2 by L1. So 1 by 6 E1 I1, okay, into 6 E1 E bar 1 plus M1 L1 square, okay, plus 2 M2 L2 square. Okay, now what we are doing, let's see here that divide by L, then we will get the first term. So let's divide by L1. So by L1 by L1 by L1. Right, now we have. So this L1 and this will get cancelled. Again L1, right? So no, here we cannot cancel because L2 is there. So L1. So with this what we will get? 1 by 6 E I 6 E1 small e1 average by L1 plus M1 L1 plus 2, this we cannot cancel, M2 L1 square by L2. So this we got the first part, right, after substituting. Similarly, if we will substitute, then what? For T32 value divided by L2. So we will get this one. Okay, another one L2 will get cancelled, and here this L1, sorry, L1 we are dividing, so L1 and L1 here also will get cancelled. So then what we have, 1 by 6 EI 6 A1 A dash 1 by L1 plus M1 L1 plus 2 M2 L1. This we will get for the first term. Similarly, once you will put this value and divide by L2, then what you will get here divided by L2, here divided by L2 divided by L2. So this L2, one L2 will cancel, L2, one L2 will get cancelled. What you will get? 1 by 6 E2 I2, and this will become 6 A2 B2 dash by L2 plus 2 M2 L2 plus M3 L2. So just see here, one thing you can just see here, whatever the corner side is there, only there is no divided by this term. So this is at the right side of the this one. So here there is no this term. So M3 L2, that is changed. Here this side M1 L1. So one will be with the same, other one will be different. Right? So now with this, what we have, this left side we have, that is T1 to 2 by L1 plus T2 T3 to 2 by L2, and that is equals to what? That is equals to H1 by L1 plus S3 by L2. So now just substitute. So that is equals to, this is for what? T1 to 2 by L1, and this is for T3 to 2 by L2. That is equals to what? H1 plus H2. And now in both the equation we had seen this 6 is there. So take 1 by 6 common from here and just cross multiply. So this will get multiplied here. Now next, what? Distribute 1 by EI with each term. So now this becomes what? 1 by E1 I1 6 A1 capital A1 by small average A1 by L1. Right, first term. Then M1 L1 by E1 I1. The next 2 M2 L1 by E1 I1. So this first term over. Now multiplying this one. So 6 A2 B2 dash by L2 into, that is divided by E2 I2. So E2 I2 L2. Next 2m2l2 by E2 I2, 2m2l2 by E2 I2, then m3 L2 by E2 I2, which is equals to 6 into H1 by L1 plus H3 by L2. Okay, combine similar term and rearrange. So just take L1 side one side, and then is M one side, M2 another side, or just whatever the same combined term is there. So here what we can combine, just here M2 we can combine only. Yeah, other things are different. So by combining this, what we can write after taking 2m2 common, right, for these two terms, 2m2 by E1 I1 common. What will be here? L1 plus L2 from these two terms, this term and this term. Because sorry, we cannot take by L1 by E1 I1 and L2 by E2 I2 because 2m2 is common. So just we have taken 2m2 common. So just, and after that similarly there is no other things common, so we cannot just rearrange that one. So after arranging here, so just m1 L1 by E1 I1 plus 2m2 common, L1 by E1 I1 plus L2 by E2 I2 plus m3 L2 by E2 I2 plus another one, this same 6a1 small a1 by E1 L1 I1 plus 6 E2 B2 by E2 I2 L2, which is equals to 6 into H1 by L1 plus H3 by L2. Now, if each constant, then what happened? Just take E constant. So, we can take 1 by E common from every term. So, after taking 1 by E common from every term, what we will have here? That this one. So, M1 L1 by I1 plus 2 M2, right, L1 by I1 plus L2 by I2, because we are taking E common constant, so means same, E1 is equals to E equals to here, E1 equals to E2 equals to E, so we can take E common from each term. Okay, plus M3 L2 by I2 plus 6A1 small a1 bar by I1 L1 plus 6A2 B2 bar by I2 L2. This is equals to 6 of H1 by L1 plus H3 by L2. Right. So now can we just cross multiply E here? So this becomes what? 6E H1 by L1 plus H3 by L2. So that is here only. Remaining terms are here. Just this E got E multiplied here. So now we have this term. So for if same E is there. Now if suppose cross section area is also same, then what happened? Cross section area means moment of inertia will be same. Then we can replace I1 I2 to only I. So after replacing I1 I2 to I, take I1 common. So from here I1 we can take common with this term. Again I1 we can take common, I1. So simply I we can take common. So after taking I common, what we have? M1 L1. So just taking 1 by I common. M1 L1 plus 2 M2 L1 by I1 plus L1 plus L2 plus M3 L2 by, not by because already you have taken common, plus 6A1 small a1 plus 6A2 B2, that is equals to what? 6E into H1 by L1 plus H3 by L2. Okay, so now what after this? So just again this we will multiply here, so this becomes 6EI and remaining term is this one, so 6EI. So this is the special case when E and I are constant. This is when only E is constant and having the different cross section area, that is different moment of inertia, and this is the generalized equation. This equation we can use for either if E is different and I is different, means different type of just beam or structures combined. So this is the general form. Now depending upon the question, if are of the same material, means they have the same Young's modulus or E value, then we can take E constant, and that same formula this converted to this one. If of the same cross section which will have the same moment of inertia, then we can take E constant and then this becomes this one. Okay, so now this is the specialized case when E and I are constant. Now the thing, this M1 is fine, M1, M2 we can find, M3 we can, but what about this term? Right, so this is the general, this for every term this will be there, whatever the force will act. That already we had seen also in the cantilever beam, that we found M dou theta and another because of the force. So now what about these two terms? So these two terms depends on the type of loading. Okay, already we had seen that at a distance A1 and B2 it's acting. So now just see what value will be this one. So for this you have to, okay, so this is this one. Now for equilibrium what happened? This must be equals to 0. So just see, for the relationship of three moment equation to continuous beam, point 1, 2 and 3 are usually unsettling support, that is thus H1 and H3 are 0 with, so unsettling support, thus H1 and H3 are 0 with E and I constant, the equation will be reduced to, means H1 and H2 if 0, this whole term becomes 0, 0 multiplied by 6EI also 0, means now this whole thing will be equals to 0. This whole thing will be equals to 0. So this is the application of three moment equation to continuous beam. Point 1, 2 and 3 are usually unsettling support. Point 1 through 2, 3 are not any support is there, that is unsettling support, and hence that height of that will be equals to 0. Right? So with that condition again we got another equation. Right? So this is the main Clapeyron equation, that Clapeyron three moment equation, generalized equation. In the special case, what? When E is constant, then this equation. When E and I is constant, this equation. And when this unsettling supports are there at 1, 2, 3, then the height also will be 0. So this will be the final one. So this is the specialized case. Now think this value and this value what we will use and how to find. So for that this table is there. Right? The first one is concentrated load anywhere on the span, means anywhere. So just take, if suppose that instead of the whole load, that load was what, like this, right? So now instead of this whole load, only one load is there, that from this side at a distance A and from this side at a distance B. So for this value 6A A by L, right? For this, if L is total span, right, there we have taken that L1, L2. So for 6A by L, we have to just write this value. You can find the moment also, you will get the same PA by L into L square minus A square. So this is for 6A A dash by L. Similarly for A B dash by L, PB. So you see the difference is PA from this side, then P into A will be there. For this side, P into B L square minus, now again this A will change to B square. So this is the 6AA by L value, this is 6BB by L value that you have to put here, right, at distance L1 or L2, whatever the length is given, right, if total length of the span is L1. Similarly, if at the center, if it will act, means at L by 2 distance L by 2, put here that similarly A as L by 2, right. So after simplifying, what you will get? 3, or just let's see. So P, instead of A, we are putting L by 2. So L by 2 by L, and here L square minus L by 2 whole square. Right. So this will give what? P L by 2L. This becomes 4L square minus L square by 4. So this L cancel. 4L square minus L square is 3L square. That will give you P, that is 3PL square by 4 and 2, 8. So let's see. Similarly here, right, in this case, replace B to L by 2. You will get 3PL square by 2. So in this case, there is no difference, just 6A, capital A, small a by L, and 6AB by L will be same. And that already we had seen at the mid span, both side moment will be same. So this is for the second case. Now, if uniformly distributed load is there, so uniform load over the entire span, for the entire span is there, then L. So for 6A, 1 by L1 value will be what? W naught, where W naught is the weight, LQ by 4. And for this case also, W naught, LQ by 4, 6B. Now, uniformly varying load means increasing triangular load on the whole span. So from here to here it's increasing. So in this case, what happened? 8 W naught LQ by 60. And in case of 6 B dash, that is 6 A B by L, that will be equals to 7 W naught LQ by 60. So for decreasing, so from this point it's increasing, for this point decreasing, so just reverse will be there. If this side it's increasing, then this will be for 6 A by L, and this will be for 6 A B by L. So now just opposite that one, so this will be for 6 A by L, and for this becomes 6 A B by L. So this value you have to remember, just you can directly substitute instead of 6 A by L and 6 A B by L values. Next is isosceles triangular load over the entire span. So in that case, how we will find? So just see, isosceles triangular load over this one. So in this case, 6A value by L value will be what? 5 W naught LQ by 32, and 6A B by L value will be 5 naught LQ by 32. So just see here, from the both side you can see, from this it's a decreasing, from here also, so either side you can see it's increasing, at the center it's a maximum, that at L by 2. Hence both the value will be just same like mid-span condition. In mid-span already we had seen, if point load is acting at the mid-span, means the value of 6A by L and 6A by B by L will be same. So similarly here also it will be same. Now if only moment is acting, so moment load at any point on the span. So if at A and B anywhere, so from this side at a distance A and from this side at a distance B, if it's acting, then 6A value will be what? Minus M by L 3A square minus L by 2. So for this side it will be clockwise, for this side it will be anti-clockwise. So hence this will be plus M by L. This A becomes what? B square. So A square becomes B square minus L square. So this is moment acting at any distance, either side A, from one side A, then another side B distance. So like suppose this total length is 5, right? Then from this side 2 meters this moment is acting. So it's obvious from this side how much distance will be there? 3. So this is your A and this is your B. So in this case what happened? Minus M by 5 into 3 A square. So 3 into 2A square minus 5A square for this side. For this case what happened? M by 5, 3, B square is how much? 3. So 3 into 3 square minus 5A square. So this will be for what? 6AB by L. Now, general uniform loading means somewhere between that loading is there. It's not throughout the span. So just see, from this point at a distance A, this load started. And from here to till here, whatever the load is there, that is what? That is at a distance up to B. So from this, just here, from here to here A, so this load is spread over what? B minus A length. Right? So from here to here A, from here to here is B. So this length will be what? B minus A. Now similarly from this side if you will take, then from here to here D and here to here C. So in this case it will be what? D minus C. So once you will take this side, D minus A, for this side, D minus C. Right? So after substituting same L in terms of, so L will what? C minus B. So after replacing this, what we will get? 6AB, that's 6AA by L is W naught by 4L into B square into 2L square minus B square. See the proper bracket. This whole W naught by 4L is multiplied with 4, even multiplied with both the term. In that also B square is common. So B square common 2L square minus B square means, or you can say 2B square L square minus B power 4 minus 2A square L square minus A power 4. So this is the value of 6AL will be there. Okay. Next 6AB by L will be what? W naught by 4L, that is same. So just see here, from this side it's given B. So b square. So this side it's a d, so d square. 2l square minus, instead of b square, d square. Similarly, a square, here a is what? Here a is this one, so here a is c. So c square into 2l square minus c square. So just see, this easily you can remember. How? Just see, w naught by 4l. Now from this side we are taking. So this side total last distance is what? From up to that load is there, that is b square. So b square into what is that? This one 2l square minus same this b square, right? Minus now this smaller distance, this already we have taken. Now this we are removing this part, then only we will get this one. So minus this a square into again 2l square minus a square. So just see, here b square, then 2l minus b square. Here a square, then 2l square minus a square. Okay. Now next, similarly for this one, w naught by 4l. Now this side, the last one is up to d, it's separate. So d square into 2l square minus d square, and then minus c square this side. So minus c square into 2l square minus c square. So like this. So for this you have to remember these value, and once now the same, that question becomes like here to here, this load is acting on this one, right? Simply supported beam is there at a distance 2 meter, 3 meter. So this becomes the case of A and B. That is the first case at A and B. Then you have to just put 6A by AA by L and 6BB by L in this formula, right? To get this equation. Once you have this equation, just simplify, you will get the answer. So the Clapeyron 3-moment equation, just here you have to add what? 6AA by L. Just remember this value. So this value is how much? See the table. In this case, PA by L into L square minus A square. So here this becomes what? This all term will be there. For this term it becomes 6AA by L. So P, what is there? Let's see. PA by L into L square minus A square. PA by L into L square minus A square. And here this I1 or E1 I1. So this will be there. Similarly, for 6A2 B2, you can replace with PB by E1 I1 L into L square minus B square. This will be the question, just in terms of the given. So now this term plus this term will get added. That is equals to 6H1 by L1 plus H3 by L2. Or if that condition, then just we have to replace this one. So final overall, this will be plus those two what we added in the previous slide. Here this value. Clear? So for any type of whatever the loadings are given, just you have to remember the value of 6AA by L and 6AB by L and substitute in this equation that equals to 0 you will get, and that is the Clapeyron 3 moments equation when unsettling supports are at 0. Means height of the observer, because of that unsettling support, height is 0. So that time this condition, or if generalized is there, then just put here, you will get the answer. So let's recall quickly once again, right? So in this, loading is given. So now just we divided loading into two parts, into sections, because it's not necessary that always that will act in the same distance. So from here to here we have taken that from this side L1 distance, from this side L2 distance. So just see, this L1 will be what? A, right? Like this, if this is the case, your load is acting, this distance is A and this distance is B, and the overall is what? That is L. So this is here L1 for this case, and B is here L2, and that's why we replace L1 L2 instead of 6A to B. So this is the question. What we did, we divided this into two parts so that we can apply the 3 moment conditions. So we assume this as first part, second part, third. Means first, second and third point. Along this we have to find the moment equation. So now just take the free body diagram, take this part, right? So at V1, V2 just vertical support. Then next what we have to take, for this one moment will be clockwise, that is M1, and from this side moment will be anti-clockwise M2 for first part. For similarly second part, this M2 will be clockwise and M3 will be anti-clockwise. Their moment diagram is here from at A1 distance B1. Then from this side, if A2 is there, it will be B2. Moment diagram equation M1, M2, M3, then M2. Where it will act? From this side, it will act as 1 by 3 distance of L. So from this side, it will be at the 2 by 3L. Similarly, for this M2, it will act as what? 2 by 3L, because from this side we are taking. So from this side, at 1 by 3L, it will act. And that only just here, this triangle, you have to remember that where it's acting. So from this side, for M1, at 1 by 3, and from M2, 2 by 3. From here, for M3, 1 by 3, for M2, 2 by 3. At 2 by 3 distance, it will act. Right? Then, now this is there. Here, this figure is important. Right? So now for this is the moment diagram. From here, L1 distance, L2 distance. So H1 was given, and this T322 is given, that S3. So this is S3, this is T322. So what is this height? That is T322 minus S3. Similarly, this is H1, this is T122. Then the height of this will be what? H1 minus T122. Now what we did? Just take this shaded triangle and that becomes the similar triangle. Why? Because this angle is same. This coincides for both. This sides also coincides for both. Means it's a similar triangle. Apply the similar triangle formula. Means H1 minus T1, H1 minus T1 by L1 is equals to T32 minus H3 by L2. Right? Just separate the term H1 by L1 minus T12 2 by L1 equals to T322 by L2 minus H3 by L2. So here after separate, just means take T1 one side and T1 side and H1 side. So this is after separating, after rearranging T1 side and H1 side. This is the equation. Now our target is to find T12 and T32. After finding, just substitute here. That's all. So for finding T12, this is the formula, right? That means all the moment will be here where it will act. Already I discussed. After that, you will get T122 here. So now T122 we have, similarly T322, that is 1 by E2I2. Similarly area A223, and here that X3, right? After again, similarly you have to put here, you will get 322 value. Once you have 322 value, just after this, after simplification, multiply and divide by 6, so that it will be in this form. Now once you have this one, just arrange the values. Let's just substitute and later just arrange. Here already multiplied by 6, and then what next? Distribute 1 by EI with the all term, with all the term, just 1 by EI multiply with all the term. After this, you will get this one. Next, what you have to do, right? So this will be the final equation. Now, if E is constant, then what we can say, just take E constant from every term and 1 by E, and after that cross multiplying, this becomes C. Similarly, if I also is constant, E and I constant, then what happened? Take 1 by EI common. After that, 1 by EI will get multiplied here, right? So finally, this will be the condition. And for that, after what? For the unsettling support, means H1, H2, H1 and H3, that height are 0, means the right side becomes 0, means only the left side will be there. So this will be the final Clapeyron's 3-moment equation. Now here the thing is, this one is fine. For finding this, that table is there, this value you have to remember for what to replace in terms of, that means if load is acting at from this side at a distance A and from right at a distance B, then 6AA by L value will be this one, 6AB by L value will be this one. If it's acting at the mid span, this L by 2 distance, L by 2 distance, just replace here A to L by 2, B to L by 2, you will get this one. For simply supported beam, this will be what? W naught LQ by 4, W naught LQ by 4, because it's uniformly distributed. Next, if for triangular, this will be from, if this side is lower and this side is greater, means it's increasing from left to right, then it will be 6AA by will be 8 W naught by LQ, 8 W naught LQ by 60, and 6AB will be what? 7 W0 LQ by 60. Then decreasing, if from left to right it's a decreasing, means right to left it's increasing, then 6A by L will be what? 7 W0, just reverse of this one. So now this will be this one and this will be this one. Okay, so this will be for the uniformly varying load from left to right or right to left. Next, the load is from both the sides, it's a increasing at the and at center it's a maximum in that case. So means in this case again it's just like what? Acting at the midspan case. So in both the cases the value will be same, which is 5 W0 LQ by 32 in both the cases for 6A A by L and 6B B by L. If only the moment is there, so from if this side it's a anti-clockwise, then for other side, that is from the side B side, it will be clockwise. So anti-clockwise minus M by L, 3A square minus L square. Now taking from B side, so this becomes plus M by L, this A square will change to B square minus L square. Now from this at a distance A it's a start, and from this side at a distance C start, means at a distance A starts and it's get over at a distance B. From this side at a distance C starts and at a distance D it's get over. For that, this is the formula, right? So this table you have to remember, right? And directly you can substitute and then you will get the Clapeyron's equation. Depending, if generally they ask in the question like just derive the Clapeyron equation, then no need to put these values, then directly you can leave it here. If they will give the condition like here, one load is acting, simply supported beam is there, load is acting at a distance A from this side and B from this side, right? Now prove the Clapeyron's theorem. Then you have to prove up to this, right? Means you have to replace the value of 6A A1 by L1 and 6A2 B by L1. This value you have to replace. If just simply they ask derive the Clapeyron's 3 moment equation, then no need to put this value, you can just leave it like this only, because this is the generalized way of the Clapeyron's 3 moment equation. Clear? So if any doubt is there in this derivation or any in previous video, you just comment in that videos so that I can give you, or you can just contact me regarding your doubts. So we'll see that doubts. Okay. So this table is important. You have to remember this table, right? Okay. So this figure and all I have taken from this one, www.mathalini.com, right? So if you have any doubt, you can refer this site also, right? Thank you. You can just, if you have doubt, you can comment on the videos, right, itself, or you can just contact me for your doubts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.